dimensionally consistent. Now, this is the expression. The expression is V is equal to 3U plus 4AT. Let's show that. And then maybe we say, show whether the expression below is dimensionally consistent and comment on your answer. And comment on your answer. Comment on your answer. So, how do we do this? We say that for dimensional consistency, or for valid equations, the dimensions on the left hand side should be equal to the dimensions on the right hand side. Now, let us look at the dimensions on the left hand side. This is the left hand side. On the left hand side we have V, which stands for velocity. Therefore, the dimensions on the left hand side, the dimensions of velocity are L per T. And then let's also look at the dimensions of on the left hand side. The dimensions on the right hand side are equal to 3U plus 4AT. So what is the U? This is U is initial velocity, whose dimensions are L per T, plus the dimensions of acceleration, which is L per T squared times times T. So let's try to do the mathematics here. This is 3L per T plus 4L. L, this is T per negative 2 plus T per negative 1. We add the powers and we get per T. Therefore, the dimensions on the left hand side are equal to L per T. Now, how do we conclude? This 7 is a dimensionless constant. So we're going to say that 7 is a dimensionless constant. 7 is a dimensionless constant. And since the dimensions on the left hand side are equal to the dimensions on the right hand side, then the equation is dimensionally consistent. Good. That is what we would conclude. But sincerely speaking, is this a correct equation? Sincerely speaking, this is a wrong equation. This could have been the first equation of linear motion, but looking at it here, this is a wrong equation. Therefore, we can conclude and say that they said we comment. How are we going to write our comment? We write the comment and say that the equation is dimensionally consistent, but it is a wrong one. We conclude and say that the equation, let me get a better marker here. The equation is dimensionally consistent, but it is a wrong equation. So what does this tell us? This tells us that one of the shortcomings of using dimensions to show whether the equations are correct is not true. Dimension analysis just shows us that an equation is consistent, but it doesn't tell us that this equation is correct. It doesn't give reasons whether the equation is correct or wrong. Why does it fail? It doesn't give an account of these constants that is saying they are dimensionless. So now, for now, let's stop here. We shall look at more examples of that kind in the next video. Thank you.